本部の目算では4ヶ月ほどでステラ8つ達成と見ているが。
なお入学までの期限が迫っているため猶予は1週間とする。7日で子供を作れぞ。
Many primary and middle school students in mainland China need to take a physical education test when entering school. According to a survey, more than 80% of students choose jumping rope in the physical education test. However, the full score standard for jump rope is increasing year by year, such as 188 points per minute in Guangzhou in 2022 and 194 points in 2023, which also poses a challenge to students. Therefore, our group embarked on the current research project, dedicated to using the scientific method of DMAIC to find the key influencing factors and try to propose improvement strategies to find the tricks to improve jump rope performance. So, which factors have the most significant impact on jump rope performance? How do these factors affect jumping rope and to what extent? How do you increase the number of rope jumps in a minute? Are jump rope performance improvement strategies effective? All these questions will be answered during the follow-up study.
Nice.
Now, let's expand our discussion of the 5 DMAIC phases. The first part is the define phase. Before we analyze jumping rope, this sport in detail, please think seriously. Do you really know how to jump rope? To explore this issue, we launched a detailed CTQ analysis, hoping to discover the factors that influence the number of rope jumps in 1 minute. Through these analyses, we identified 7 main influences on jump rope performance, which are rope length, speed strategy, holding method, warm-up preparation, individual status, single or double jump, wearing sportswear or not. In the later stages, we will analyze the relationship between them and jump rope performance. Next, it's the measurement phase. Here we talk about the quality function deployment (QFD) research process used to investigate ways to improve jump rope performance. We started by identifying the customer requirements, such as rest and recovery, proper form and technique, reduce the number of interruptions, mental focus and concentration, and proper equipment. We created a list of technical design elements such as the rope length to height ratio, speed strategy, and holding method, and so on. Afterward, we demonstrated the relationship between the customer requirements and technical design elements in a matrix to identify the most important technical design elements to meet customer requirements. We prioritized customer and technical requirements based on their importance to customers and feasibility of implementation, and finally evaluated our results to develop a plan for implementing the most effective technical design elements and the 3 most important technical design elements for meeting customer requirements: rope length to height ratio, speed strategy, individual status. The third part is analysis stage. Firstly, I would like to share with you the research process that I went through while conducting a study on jump rope performance, using a fishbone diagram. To begin the process of creating a fishbone diagram for this study, we analyzed the manpower, materials, methods, machines, measurements, and place of jump rope. We developed strategies to improve jump rope performance, including proper technique, use of suitable equipment, effective training methods, and so on. From the Pareto diagram, we can see that 4 important factors account for 70% of the importance. In the next section, we will move on to the improve stage. We will firstly define levels of the main factors, and then use DOE to determine the effects of each factor on the yield. Based on the analysis results, we will then simplify the model. The main factors levels are set by their types. Length-height ratio is defined based on rope and chest height, with 1 representing chest level and -1 representing above/below. Speed strategy is set by 1 for slow to fast and -1 for fast to slow. Personal status is -1 or 1 for poor or good. Next, we will conduct DOE. The main effects plot shows that length-height ratio is the most important factor and is positively correlated with the number of jumps. At the same time, better results are achieved when the speed strategy is slow to fast. The importance ranking of each factor can be obtained from the Pareto and normal plots. P-values in the coded coefficients give that single factors and interaction factor AB have significant impact with p less than 0.05. Based on the previous statistical analysis, we will remove the combination variables of AC, BC, and ABC to simplify the model and obtain more degrees of freedom. It can be seen that the p-values of the retained variables are still less than 0.05, and the residual plots show a normal distribution. These results indicate that the simplified model is also good. Finally, let's turn our attention to the control phase. This part of the experiment aimed to verify the validity of the optimal strategy obtained during the improvement phase. Therefore, we invited 10 people. To exclude chance, each person was tested separately for 2 different days, that is, let each person correspond to 2 samples, a total of 20 samples. Each sample was tested 10 times, and 200 sets of data were obtained. According to the judgment criteria of control charts, the original data are discrete and the sample size is constant, so we choose NP chart to process the data. Since the full standard of jump rope test in high school entrance examination is 180 times per minute, we regard the test results below 180 times as defects, and we can get the graph on the left side. From the graph, we can see that all the data are within the upper and lower limits, and the overall number of failures for most of the samples is less than or equal to 3. We found that the output results obtained by our optimal strategy were in control, and most of the samples were able to get full scores in most of the tests, which also proved that our improvement was effective.